Welcome to section 13.1 Polyhedra and other solid shapes. Here are the topics, standards, and vocabulary. In this section, we're going to study some familiar solid shapes of geometry, most of which are the common in sets of building blocks, and some may be less common. So initially, young children may only view solid shapes holistically, right? As teachers, we draw their attention to the components. They may just see, oh, it looks like this. But what we're going to bring their attention to is the points, the edges, the outer surfaces, and what those look like. And as they become aware of these different aspects and how they affect whether the shapes can be stacked or under, whether they can roll, and those kind of components lead to those understandings, and that's what we're going to be discussing here. So some solid shapes have curved outer surfaces, whereas others have flat surfaces consisting of triangles, squares, rectangles, pentagons, or other polygons, and that is what we call polyhedra. So what are polyhedra? They're closed, connected shapes in space whose outer surfaces consist of polygons. And we call those polyhedra or polyhedron. The plural is polyhedra. So, okay, we're looking at two polyhedra and a shape that is not a polyhedra. So notice here that the sphere is not a polyhedron because it is curved. All right, a circle is not a polygon. So on these two are our polyhedron. The outer surfaces are called faces. So this would be a face. And then the place where the two faces come together is an edge. So let me get a new color here. This would be an edge. And then a corner point where they come together is a vertex. So that right here would be a vertex, vertex, vertex. Here we have an edge. And so the plural of vertex is vertices, and this is based from Greek. So poly means many, hedron means base, so polyhedron means many bases, right? So given a polyhedron, students can study its characteristics and qualities. They can, let me get my yellow back up. They can observe its faces, it can observe its edges or vertices. They can look at the kinds of shapes of the faces, how many vertices, how many edges. So we're going to talk about two common polyhedra. We're going to talk about the prisms and the pyramids. And then also related to these are cylinders and cones, but because they have curved surfaces, we do not call them polyhedra. So let's start by talking about right prisms. So first, a special type of polyhedron is a prism. You may have seen these around your home. From a mathematical point of view, a right prism is a polyhedron that can be thought of as going straight up over the polygon. So you can think of it as they're formed in the following ways. We're going to take two copies of any polygon. So in this case, it would be a triangle, two copies, or a rectangle, or a pentagon. And we're going to lay them both flat on a table, and then we're going one on top of each other, and then we're going to move the top polygon straight up. And if vertical rectangular faces are now placed to connect those two polygons, so we are kind of moving this base up. And you can see that all of the faces besides those bases are actual rectangles. These are right polygons, and the two polygons that you start with are called the bases of a right prism. Now you can have an oblique prism, and you can kind of see in these two pictures here that it's kind of the same idea, but we're not going straight up. So we would move the top polygon up, but without twisting away from the bottom. So we might move it maybe in this direction or in this direction. So once again, its faces are now placed so as to connect corresponding sides of the two polygons, and that way they form the prism. Every right prism is a prism, but some prisms are not right prisms, and these are called oblique prisms. So prisms are often named according to the kind of polygons that make the bases. So for a prism with triangular bases, we would call it a triangular prism. A prism with rectangular bases, we call rectangular prisms. And so you just want to be really careful that we're using proper terminology. So a common error is to call a rectangular prism a rectangle. But remember that a rectangle is a two-dimensional shape. The face is a rectangle, but the prism itself is three-dimensional. You can also move its orientation. So notice that in this case, the bases are not on the ground, but it's still a prism because we have two polygons with the same base that extend out, creating in this way rectangles, rectangular faces. Now, a cylinder is a kind of shape related to prisms because it's tube shaped, and there's pictures on the next slide here. But a tube inside a roll of paper towel, and you can kind of get the idea that a cylinder is a closed curve on a paper, maybe a circle or an oval. If you cut it out, make a copy of it, lay it on top of each other so that they match, and then take that top copy and just move it straight up, you're going to end up with a cylinder. So as with prisms, a cylinder can be a right cylinder, an oblique cylinder, right? So our bases go straight up in a right cylinder. They go to the side with an oblique. And remember, you can just kind of place it on its side. In your head, you may need to like mentally turn that over to see kind of what's going on. We also have pyramids. Now, this is a special type of polyhedron, and there are famous ones in Egypt. And there are variations. So pyramids can be described as follows. We're going to start with any polygon and a separate single point. We call this point the apex. So again, we're starting with any polygon, triangle, rectangle, square. And that point, that apex, does not lie in the plane of the polygon. So we're not taking, you know, a polygon and then an apex directly inside of it. That apex needs to be somewhere outside of the plane. Then we're going to use additional polygons to connect the apex to the original polygon. So this should be done in such a way that all the lines connect the apex to the polygon, lie on the sides of these additional. So we would have, in this case, we would connect it to each one here, and that's how we could get our pyramid. So we could have a right, meaning it's going to go straight up, rectangular, that's talking about the base, pyramid, goes to an apex. We could have oblique, meaning it's going to move towards the side, rectangular, meaning it's going to have a rectangle base, pyramid means it's going to an apex, right, meaning it's going straight up, triangular, meaning that's the base, pyramid, meaning it's going to a single point. Cones are related to prisms. They're shapes that are related actually kind of more closely to pyramids. So excuse me, cylinders are to prisms as cones are to pyramids. So it's kind of that round idea of a pyramid. So cones can be described as starting with a closed curve in a plane and a separate point that does not lie on that plane. We know that's the apex. We imagine paper, some kind of material that joins the point to the curve in such a way that all the lines connect to the point to the curve lie on that paper or whatever that material is. So as you can see here, we have our right circular cone. Right meaning we're going straight up. Circular meaning the circle is a base. Cone meaning it's going to an apex. Oblique meaning it's going to the side. Circular base. Cone meaning it's going to an apex. And now in this case, we just have a right meaning it's going straight up from the base. But we don't have the base. We don't have a name for that shape, so we're just calling it a right cone. There are all sorts of other shapes that we see in the world around us. They could be combinations or portions. You could view a tree trunk as a kind of like a cylinder or the bottom part of a tall cone. The legs of a chair might be a square prism, or a bottle of juice might look kind of like a cylinder with a cone on top of it. So we can kind of think of these in all different ways as we look at the world around us. And we're going to go into several examples when we come back into the next video.